Welcome to the Math 104 Final Exam Review, Part 2. We're working on Chapter 4 this time. We'll start with number 15. We're going to simplify this expression. So first thing we can do is do 12 divided by 3. That's going to give us 4 in the numerator. And now we can do power to a power here, multiply the exponents. -2 times -5 is +10. Now we can combine all of these exponents together. We're going to use the product rule here. Add the exponents. 10 plus -3 is 7. So that's 4k to the 7 divided by k to the -4. And now we subtract exponents. So 7 minus -4 is +11. So that's 4k to the 11. Number 16. So with this one, we've got some negative exponents here. We can combine these. So -3 minus -1 is -3 plus 1. So that is 5z to the -2 power. And then over here, this is also 5z to the -2. Just all I do is take that, move it to the numerator, make the exponent negative. Now we've got product rule. So we'll add these exponents to get -4. 5 times 5 is 25. So it's 25z to the -4th power. And to simplify, this goes in the denominator. And we get 25z to the 4th. Make sure when you move that to the denominator, you change the sign on the exponent. Next up, number 17. So we've got an exponent on the outside here. Before I apply that, I want to simplify on the inside. So we'll subtract these exponents, -4 minus -9. That's 5. So 6n to the 5th. And that is to the -1 power. Nothing to do there. And so what's going to happen when we apply this -1 power, this is all going to go to the denominator. Right now we can combine these two. Quotient rule, so subtract the exponents. -2 minus 5 is -7. That gives us 1 over 96 m to the 7th. Number 18. Before we start applying these outside exponents, better simplify on the inside first. So we use the quotient property here. 5 minus -3 is 5 plus 3, so it's r to the 8th power. That's 3, r to the 8th, 5, still to the -2 power. And then over here, we can combine these. -1 minus -5 is -1 plus 5, so it's r to the 4th power. So 9r to the 4th over 2, still to the 3rd power on the outside. All right, now the negative exponent, that just means we flip the fraction. And now we can apply these outer exponents. So 5 squared is 25. 3 squared is 9. R to the 8th squared, that's power to a power, multiply the exponents, and we get r to the 16th power. And then over here, 9 to the 3rd power. That is 729 power to a power, r to the 12th, over 2 to the third, 8. Now what we can do now is do some simplifying. 729 divided by 9, that gets us back to 81. So that's going to give us and now we can do quotient property, r to the 12th divided by r to the 16. That's going to give us r to the 4th power in the denominator. And 25 times 81 gives us 2025. So it's 2025 over 8r to the 4th power. Number 19. Oh, we're going to multiply numbers by numbers. -3 times -4, that's -12. Like bases by like bases. All right, we got some x's here, so we'll add the exponents. 4 plus -2 is 2. So we get x squared. Now we'll do the same thing with the y's. 3 plus 5 is 8. -12, x squared, y to the 8. Number 20. The numbers first on number 20. We got 6 divided by -3 is -2. Now we're going to combine the m's using the quotient property. -4 minus the exponent on the m is an implied 1. So -4 minus 1 is -5. So we get m to the -5th power. And we'll do the same thing with the n's. Quotient property, subtract the exponents. 3 minus 2 is 1. So we get a single n there. Now to be fully simplified, we need to move the base with the negative exponent to the denominator and make that exponent positive. So we get -2n divided by m to the 5th. '21. So with something like this, what we should do first is simplify this numerator. That's going to be a lot like number 19. And then we'll deal with the denominator. So first up, numbers by numbers. 20 there. Add the exponents here, we get p to the 3rd power. Add the exponents here, we get q to the -2 power. That's gonna be a lot nicer to deal with now. Divide the constants, get 10. Now we use the quotient property here. 3 minus -5 is 8, so that's p to the 8th power. And we'll subtract here as well. -2 minus 5 is to the -7. And the last thing we need to do is move this down to the denominator and make that exponent positive. So 10 p to the 8th over q to the 7th. (22). These expressions are very similar. There's an important difference. With this, the base is the entire thing inside the parentheses, -6. Anything to the 0 power is 1. This one, however, the base is 6. 6 to the 0 power is 1. Then we have to multiply by -1. So we get -1. All right, moving to section 4.3 now on polynomials, starting with number 43. Right, so this is the vertical method for combining polynomials. All right, we're adding these together. It may be a little confusing if you have a subtraction there. That just means this term is negative. We're actually adding together the. All right, so we'll just combine like terms. So the x squared terms here, 3 minus 4 gives us -1, so that is -x squared. And here we got -5 plus 2, so that's -3x. And 6 plus -5 is 1. -x squared minus 3x plus 1. 44. Well, this one we're subtracting. And the problem doesn't show up. I'm going to stick in some placeholder zeros here. Where we see a missing term, put in a 0. And with this one, we are subtracting. So we got -5 minus 0, so that's still going to be -5 y to the 3rd. And we got 0. Nice to have a placeholder here. Then we're subtracting from something. So 0 minus 4 is -4. -4y squared. We got 8 minus 2, so that's 6y. And -3 minus 9 is -12. -5y to the 3rd minus 4y squared plus 6y minus 12. And that brings us to number 45. So these 45 and 46 are presented in horizontal format. Feel free to do these any way you like, horizontal or vertical. All right, subtracting here, I put in a couple of placeholders. And we got 4a to the third minus negative 2a to the third. That's negative 4 plus 2. So that is 6a to the third power. We got 0 minus 4, so that's negative 4a squared. Negative 9 minus 7, that is negative 16a. And we got 15 minus 0 is 15. 6a to the third minus 4a squared minus 16a plus 15. $46. All right, we're adding here. 5 is this 8y squared. Negative 2 plus, or positive 2 plus negative 11 is negative 9. So that's negative 9y. And negative 1 plus 6 is just 5. 8y squared minus 9y plus 5. Next up, we've got some involving function notation. Just keep in mind, these are the exact same problems, they're just presented a little bit differently. So for 51, we define f of x to be 2x plus 3. And we're defining g of x to be 5x squared minus 3x plus 2. Part A, we're going to find f plus g of x. So f plus g just means we're adding those two functions together. So we're doing basically exactly what we did over here. It's just presented with different symbols. So let's add these two together. All right, nothing to combine with the x squared. Now we got some x terms to add together. And then we got some constants to add together. 5x squared minus x plus 5. All right, part B, now we're going to subtract f minus g of x. So for this one, we go ahead and write it out. There's f. We're going to subtract g. All right, subtracting this then, 0 minus 5 is negative 5x squared. And we got 2 minus negative 3, so that's 2 plus 3, so that is positive 5x. And then 3 minus 2 is 1, plus 1. Negative 5x squared plus 5x plus 1. C. Now C is the function f plus g that we found in A, and that's evaluated at -1. So we're going to take our answer from A and plug in -1 here. So that's 5 times -1 squared minus -1 plus 5. All right, -1 squared is 1. 5 times 1 is Subtracting a negative is adding, so plus 1 there, plus 5. So we got 5 plus 5 plus 1 is 11. And then D is f minus g at -1. So f minus g is this one. Plug in -1 for all the x's. All right, we got -1 squared is 1 times -5 is -5. 5 times -1 is -5, so we got -5 minus 5 plus 1, and that is -9. And on to section 4.5. Now we're going to be multiplying polynomials. Two x times x plus 4 times x plus 7. Well, we can distribute in first. Doesn't matter if you FOIL to distribute first. Do either way. Distribute first, you get 2x squared plus 8x. Still times x plus 7. And now we can FOIL. All right, first times first. That is 2x to the third power. Outside. Plus 14x squared. And inside plus 8x squared. And last plus 56x. Combine the two x squared terms together to get 2x to the third plus 22x squared plus 56x. Next up, 59. And we're FOILing again here. First, 3w times 2w, 6w squared. Outside, -9wt. Inside, -4wt. And last, plus 6t squared. Keep in mind, it doesn't mind if you write these tw or wt. Multiplication is commutative. So we get 6w squared minus 13wt plus 6t squared. Next up, number 60. All right, FOIL. First, it is 10p to the fourth power outside, minus 8p squared inside, plus 30p squared, and last, minus 24p. And we'll combine those two middle terms. There we go. 10 to the fourth plus 22p squared minus 24p. plus yep, screwed this one up. Okay. Forgot that p there. I missed that. So there's 10 outside, inside. This will be p to the third. That was one. Switch these around to be in descending order. $61. All right, we got 3 terms here, 2 terms here. So when we multiply, we're going to get 6 terms in our first answer here. So 3q squared times q gives us 3q to the third power. All right, now 2q times q, that's plus 2q squared. And q times -4 minus 4q. And multiply by -5, so that's -15 q squared. And then -5 times 2, so that's minus 10q. And then finally, -5 times -4 plus 20. Now we can combine some like terms. 3q to the third. There's nothing to combine with, that'll stay as it is. Now we can do 2 and -15, so that's -13 q squared. And now combine the q's, so you get -14q and plus 20. $62. Now in 62, this will be a little easier because we have the factored form of difference of squares. So that means all we have to do is multiply first times first, and we get 36r to the 4th power, and subtract last times last. 36r to the 4th minus 1. $64. 63. All right, 63. 4m plus 3 squared. All right, so this will be a perfect square trinomial. So we're square the first. It's 16m squared. And of course, you can just do this by foiling. If you just want to write it out as 4m plus 3 times 4m plus 3 and then foil. You can do it that way too. But since it's a perfect square trinomial, we can just use the formula. First term squared, last term squared, first term times last term times 2. 64. Okay. 3t minus 2s squared. All right, first squared, you got 3t squared, that'll give us 9t squared. Now, first term times second term, that is 6ts, double it to get 12, ts or st, st, 12st. And then this one squared gives us plus 4s squared. All right, next up, number 69. Back to function notation now. And we're defining f to be f of x is 12x squared minus 3x. G of x is 3x. And so for 69a, we want to find f times g of x. Right, so we're multiplying f times g, so that means we're multiplying f times g. Multiply those two functions together. So this is the same as 3x times 12x squared minus 3x. Distribute in. That's 36x to the third minus 9x squared. And now we're going to find part B, find function f times g evaluated at -1. So that means we're plugging -1 into this thing. All right, -1 to the third is -1, so that is -36. And 1 squared is 1, so -36 minus 9 gives us -45. Now we do some division, starting with number 65. First one is dividing by a monomial. So the way to do these is to split up into 3 separate fractions. 4y is the denominator of each one. And then simplify each one separately. So do this one, 4's cancel, y a third over y is y squared. Over here, 12 divided by 4 is 3. Y squared divided by y is y. And over here, the y's cancel. 5/4 cannot be reduced, so it stays a fraction. Y squared minus 3y plus y fourths, or plus 5/4. 66. All right, now we're getting into polynomial division. All right, polynomial division. We want to match the leftmost term. Multiply the leftmost term of the binomial. All right, so x to the third divided by x, we get x squared. So that's what we're multiplying by. All right, now we take x squared, distribute into x minus 5. is x to the third minus 5x squared. Now we subtract. X thirds go away. -9 plus 5 gives us -4x squared. Now break down the next one. Plus 26x. Now we need to match -4x squared. So -4x squared divided by x is -4x. So -4x goes up here. Distribute -4x into x minus 5. Careful of the negatives. Here we're subtracting a negative. That should give us a 0 here. 26 minus 20 is 6x. Bring down minus 30. Now we need to match 6x. So we're going to multiply by 6. That gives us 6x minus 30. Those match. So that means we have a 0 remaining. Our answer is x squared minus 4x plus 6. All right, 67. And we got a missing p term, so I'm going to plug in a 0p there as a placeholder. Just to be very helpful in these. Now we need to match 2p to the third. 2p to the third divided by 2p is p squared. So p squared goes up here. All right, the 2p to the thirds go away. Now we got 9 minus -3 is 9 plus 3 or 12 p squared. Bring down the next one, bring down the 0p. Now we need to match 12p squared. 12p squared divided by 2p is 6p. 6p goes up here. Now subtracting 0 minus -18 is 0 plus 18, so we have 18p. And 27 there. Now we need to match 18, so we're going to multiply this by 9. Plus 9 gives us 18. Minus 27. Now it looks like we're going to get a 0 here, but we're subtracting -27. So that is 54. So we do have a remainder in this one. So our answer will be p squared plus 6p plus 9. The remainder is positive 54, so plus 54 over divisor 2p minus 3. $68. Now this one, we've got a missing term in the divisor. So I plugged in a 0 for the p term. It's helpful. And we want to match 5p to the 4th power. So 5p to the 4th divided by 5p squared is p squared. So p squared goes up top. I'll distribute p squared into here. That gives us 5p to the 4th plus times 0, 0p to the 3rd. P squared times -3 is -3p squared. Subtracting, that goes away. 15 minus 0 is 15, so we get 15p to the 3rd Negative 33 minus negative 3, that's plus 3, so negative 30 squared. And then bring down the next one, minus 9p. Now we need to match 15p to the third. So 15p to the third divided by 5p squared is 3p. All right, distribute 3p. All right, subtracting those go away. Negative 30 minus 0, so that's negative 30 p squared. Negative 9 plus 9, that's 0, so this is 0p. Then bring down 18. All right, now we need to match negative 30. So negative 30p squared divided by 5p squared is negative 6. And those match. And do zero remainder. So our answer is p squared plus 3p minus 6. And now we're on to number 70, and we're back to function notation. So for number 70, we've got same function definition, so 69, f of x is 12, x squared minus 3x, and g of x is 3x. So we're going to find f over g of x. All right, so that is f of x divided by g of x. We're just going to divide these. So that gives us 12x squared minus 3x over 3x. All right, now split these into two separate fractions, both over 3x. And simplify each separately. So over here we get 4x. Over here we get 1. So 4x minus 1 is f over g of x. Now we want to find the value of this at 2. For b, we're doing f over g. Evaluated at 2. So here's our f over g function, 4x minus 1. So that gives us 4 times 2 minus 1, minus 1, or 7. So that wraps up part 2. Stay tuned for part 3.